Alright, welcome back, it is your boy the Prokon Geek, and welcome back to the channel. We are now doing another video on foundations. Okay, what's up guys, welcome back to the channel. This is the Prokon Geek, and in today's videos we're going to be looking at corrections, clarifications, and some mistakes that are common when you're designing and going through your foundation. So don't worry about it, we're not going to take too long, but I just wanted to make sure that we clarify on some things, such as the common mistakes that happen when you're designing your foundations, so that before we move on to the column starters and every other structural element of our building, we kind of have an idea of the best practices, and also it makes you it helps you to be different from someone who just keys in data into the program. So let's just wait for it, and alright, I think I'm taking too long. Let's not take too long, let's just get into it right away. Okay, so to get started, the first thing that we need to address is the loads that we entered into the system. So yes, don't worry, it's not a really big thing that you need to worry about. But the first thing that I want you to notice is this is column 1 base. This is base 1 with column 1. So you're going to go to column 1, base 1. So there's one thing that you need to take care of. That is, you really need to make sure you enter the correct loads. So disclaimer, nothing is wrong with our calculations. All our calculations are okay, they're correct. But then there is one error that we always talk about, especially when you're going through engineering school or any science-based school. That is human errors. What is the error that I'm talking about? The error of transposition. So if you look, this section is this 336.05 is the dead load calculation, whilst 1979.60 is the live load calculation. But what happened is, if I come and check my what is this? If I come and check my Prokon design file, you will see I entered 336.05 as the live load. You see live load plus DL, and I entered 179.60 as the dead load, which is wrong. So it's not much of a big deal. It's just an error of transposition. So all we had to do is just switch up these things. So the only problem that came from doing this is that we sort of had an over design. That is what happened. We over designed our foundations. Okay, but well, it's not really a bad thing, because an over design is better than an under design, but it just kills the client when it comes to materials such as concrete and everything. So apparently that is what we did with all our columns. So I'm just gonna make sure, let me just save this one as first. So let me just make sure I save it, and then let's design it. But if you check, we're still good when it comes to shear, when it comes to the moments, and when it comes to, there's nothing that is in red, so we're still good. So there are calculation sheets, and then we go to our bending schedule, and we see that we need Y16s at 350 and at 350. But I'm going to talk about also this configuration. We already talked about having 4 bars in one direction and 3 bars in one direction, but I'm going to talk as well about the spacing of the bars and also the sizing of the bars. But right now we just need to make sure that we correct the loads that we entered. So the same thing happened for column 2 as well. Let me just go to column 2. You will find that I switched up the live load with the dead load. So another thing to notice, if you find your dead load or your live load being bigger than the dead load, usually you have made a transposition mistake. Transposition just means putting a number in place of another number and switching them up. For example, if you needed to enter 12, you end up entering 21 or something. In this case, we transpose the dead load with the live load. So it's just a matter of, let me just Control C, Control V there, Control C, Control V, then Control C, Control V, then delete everything, then cut this, then paste this, and we're good to go. Then you save it. So same thing as well has to happen for column, this is column 4. It's the same thing. The live load has to be smaller than the dead load. Control X, Control V, and cut this, and then you are good to go. That's, we have saved. Control S to save, and then let's deal with column 3 as well. Yes, so the live load is smaller than the dead load, so we also have to make sure we change that. So this is okay. Control X and then Control V, and then once that is done, you are good to go. So this is the first thing that I wanted to address, and now let's move on to the next thing. Alright, to address the next thing, it's mostly going to be between column 3 and 4. There was an issue, if you remember, in the last video where I was like, this is 38.4, and for column 4 is 38.4 as well. So that's the thing. When you find those become as if they're suspect results. So what I had to do is I just had to come back and see where did this. So obviously the live load is given by the slabs and the roof, so I had to check the calculations to see if I'd entered the same things, but then I found out I had entered different things. So this is the thing. So for column 4 it's 5.625 multiplied by 0.75. I just verified it by AutoCAD, the areas that we needed, they're correct. And then when you come to column 3, it's what? It's different. It's 1.875 by 2.25. So that is the funny thing. 1.875 by 2.25 gives you 4.21875. As you can see, it's a multiplication between these two. And this is a coincidence, 5.625 multiplied by 0.75 gives you the same area. So since all of these are aerial loads and they're based on the area that is contributing, or the tributary area, the result was going to be the same. So that's the other thing. Whenever you find the results seem to be suspect, always go back and check whether your calculations are good. So this is the thing about checking your calculations. It helps you. And the good thing is when you have your things computerized, whether in Excel or in MathCAD, when you make a mistake, it's just as easy as going back and keying in. So for example, if this was now 0.5 but 1, I would have just easily keyed it in and the load would have changed. All I had to do was go to Prokon and change it up. But in our case, everything was correct and everything was good, so we were good to go. So that is the other thing I want to check, that verifying loads whenever you think they're suspect is very good, and you should always keep that in mind. So always check your calculations when you are doing these things. Alright, so now let's move on to the third thing. Alright, now we gotta talk about the third thing, my brothers and sisters. Alright, so the third thing that we need to address now is the base sizing and detailing, but let's just start off with sizing the base. So you find that when you're sizing your base, what is the first thing that you need to do? Well, sizing the base, basically according to most codes, whether it's SANS or BS, it's just it goes down to choosing a suitable base area that is L multiplied by B, such that the maximum allowable working ground pressure PB is not exceeded. And the maximum allowable ground pressure is what you get from, what do you call this? From the geotechnical documents or investigations. And this is what you put in Prokon under maximum serviceability limit state bearing pressure. And if you remember from what we did, we put 750 because that is what is coming from the geotechnical investigations. Okay, so that is basically what you do, and I did take care of that in my sheets. As you can see, area is given by force over pressure, because pressure is equals to force over area. And if you work around those things, I think most of you did, what do you call this, physics, and you know the basics of dealing with pressures, whatever it is. You understand making subject of the formula, which is what you need to do. So it is easy. There is nothing that's too much that you have to do or worry about when you're doing it. So as you already know, let me try and pop up something on the screen. As you know, you reason that if P is equal to F over A, then the following is also true. Force is equals to pressure multiplied by area, and then the following is also true. Area is equals to force over pressure. So in our sheets, what we have to do is you enter the force that is exerted by your loads, then you divide that by the pressure, then you get the area. But then you just assume a square base, so that at least you know L squared is equals to A. Therefore, the root of the area will give you the length of each side, which is what we do when we preliminary size. So as a rule of thumb, you always round up your figures and you start by putting those figures in Prokon where it requires you to put the base length of A and the base length of B. So that is what I just wanted to clarify. How do you first size your base? Then now the next thing we need to do is about the cover. All right, so when you're talking about the cover now, or the other thing that is important is base depth, which is Y, base depth Y. how do you do that? Even, for example, if you still remember, there was a base where I think, let's see, right now we have 0.25. I'm going to choose the smallest loads. I think the smallest loads would come from column 4. So if you go to the smallest loads, I think we can see base depth. I put it at 0.15, and yes, we don't have any red figures, so 0.15 would work. But wait, this is where ingenuity starts coming up. You cannot have a 0.15 base. Reason behind that is, check, the minimum cover you can have in your foundation is 50, because your foundation is not going to be mildly exposed. It's going to be under severe conditions where you got water tables and it's under the ground. So the minimum cover you can have is 50. And then that is 50 underneath. Sometimes it's actually 75 underneath, then 50 to the sides and 50 from the top. So I'm just going to open up a drawings to illustrate what I mean and show you why 0.15 cannot work. So what I'm going to use is a base that is 250, as you can now see it on the screen. And then this yellow line represents 150 from the ground. So in a case where you need a single cage and you put a cover of 50 at the bottom, and then you have your U-bar, your 38 shape code 38 bar, 7 is the main bar. Then you also have these bars. This is a section, so we just cut through. So as you can see, when you have a U-bar, you need a minimum anchorage length, which is equal to 10 multiplied by the diameter of the bar. And in our case, we're using diameter 110, or this was supposed to be 12, or you can just use 10s as well. If we put 10s and we put the minimum to 1 in 100, all right, and then you put 100 as well, I'll check what happens. You see, your bars will be going to the top of your base. You're basically not putting any cover. You're not providing any cover at the top of your base if you provide a 150 millimeter base. So as you can see now, that's the thing. 150 millimeter base depth works for these loads, but it is not practical. You need to do something that's practical as well. So that's when you start thinking as an engineer, okay, I need to provide something that is practical. So it's not just about keying in the values and getting something that works, because 150 would not work. So you also need to take into consideration the covers that you're going to be putting as well. And it's even worse when you have a double cage, because this is what a double cage would have to look like. So even if I change this to 100 and change this to 100, this is what happens. Let me just show you. You still need to provide the top bar. So you already, if you put 150 millimeter base, it's not going to work. It's not going to be practical because you need a double cage. So to provide for that, what you have to do is you have to do your mathematics. Say, all right, I need to take off 50 from the top, 50 from the base. So at a minimum, I need 100 millimeter thick base, but then I need to provide anchorage bars for the top cage and the bottom cage, which is 100 and 100. So you then come off to 100 plus 100, or you start working yourself. Okay, maybe I need 50 plus 50. So that would give me 200, then an extra 50 to work with. So in this case, we see that the minimum base size we can use, even though a 150 millimeter dip base works, is a 250 millimeter dip base. So those are some of the things you need to think of when you're designing your things. So next time, don't just key in the values. Yes, 0.15 works, but when you're going to detail it, you're not going to be using 0.15. So in this case, we need to change the base depth to 0.25. And we are still good. The good thing is what you actually see is whenever we increase the depth of our foundations, let me just put 0.15. At 0.15, you have shear. As you can see, where I'm just clicking, you have shear at the faces. But when you increase the depth of your foundation, you take care of the shear actually decreases. All right, so that is one thing that we also needed to note. And that's the thing you also need to think of when you're given the base depth of your foundation. So next time, it's not just about keying it in. That's something that you have to think of as well. So I just wanted to highlight that, something that we overlooked because we're just doing it fast. But now that's why I'm putting this video, so that I clarify and you also understand and see that mistakes happen and you always need to recheck your things. So let's move on to the final thing. All right, now for the final thing when it comes to detailing, you know, when the thing goes, it go pa 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 pa. All right, for the final thing we're gonna do is we're gonna look at detailing. So if you still remember, in this case, I think the 3D representation will help us see what I'm trying to say. So in this case, it's saying give us 3 bars, but you see from the spacing, I just want you to check, you have 1 bar that is at the center of your column, which is not very good, ladies and gentlemen. This is the thing that happens when you are detailing. This is some of the things you need to remember. So I'm just gonna screen grab it and put it up. When you're detailing your reinforcement, right? Usually this happens when it's rectangular, or it's when you do have one side shorter than the other. But generally, what you want to do is a greater proportion of your reinforcement should be placed centrally below the column, because the reason for this is that the curvature of the footing is greatest directly below the column and reduces as the distance from the column increases. So yes, it's good to have bars at the end, or further from, what do you call this? Let me just see, further from the center, as you can see right now. But the best place where you need your bars is going to be at the center of the column, the center, because this is where the curvature is. So in our case now, the best thing for us to do, if we put 10s, that's okay. Let's put 10s. Let's put 10s. The best design, because the minimum bar size, so 10s, right now we are failing at y10s at 300. So all we need to do is just reduce the distance, or the separation distance. So in this case, we're going to put y10s, shift at, let's put 150 and see how many bars we get. We get 3 bars, so I'm just going to change that, and we get 150 as well. So as you can see, when you put y10s at 150, you are providing reinforcement. That's a little bit too much. So let's put it at 200. So at least we have 2 bars, because already it's a lot of reinforcement that is not needed. So you have entered 393 square millimeters per meter, so you're kind of good to go. So this setup ensures we have more bars at the center of the column, so therefore we are taking care of the curvature. I hope you now understand what I meant by the detailing. But at the end of the day, what you can actually do is you can shift the positions of these 2 bars to make sure that you may not even have as many bars at the edges as compared to the center. And that is what we do when we're detailing now in pads. So one thing you need to note is that it's good to generate the bending schedule from the bases, but the best thing that I do is just to save this so that we see if our entered bars are enough and what is required and what is the nominal. So just make sure the entered bars are greater than the nominal reinforcement and also greater than required reinforcement. So in our case, the required is very low, but then there's what they call the nominal reinforcement. This is the minimum reinforcement that you can put. So in this case, 393 is greater than 325, so we're good to go. So all we have to do is now we will be detailing it and making sure that our parameters are okay. So when we start detailing, that's when we come to the detailing using the sands or whatever you use. So as you can remember, the minimum diameter of the bars for all types of foundations, the diameter of reinforcement other than mesh should be at least 10 millimeters. We're good to go. And then there's also requirement for an anchorage. So the bar that you usually normally use shape code 35, but now we use shape code 38, because 35 is, let me show you the difference. Rebar bar. This is 35 and this is 38, because 35 does not specify the length of the legs, 38 specifies the length of the legs. So that's the other thing that you need to take care of when you are detailing. So these are some of the things we're going to be looking at, and this is the reason why it's always good. Prokon will always design something if you enter values in it. 2, if you don't use your own common sense and thinking when you're designing these things, you're probably going to come up with mistakes or provide something which is not practical on the field. For example, providing a 150mm base where when it comes to site it doesn't work because you already specified your cover needs to be 50 at the bottom or 75 at the bottom. As you can see when you're using the minimums, let me just go back to the bending schedule. We have a bottom of 75, sides at 50, top at 50, the columns at 30. So those are some of the things I just wanted to highlight before we move on to doing the starter columns, so that you guys have an idea what happens, and also so that everybody sees some of the mistakes which are common, and so that we don't make those mistakes as we go forward. Because my purpose is to make sure that you guys understand, and it's not just about me teaching you to do the software so that I get views. No, I want you guys to understand the basics of what we're doing, and also just make sure that everyone is in line with the actual principles of structure, because that's what engineering is all about. It's about economics, integrity, and also reputation. just making sure everything is nice and cool for both you, the client, and the contractor. So that's your job. So until next time, you know what it is, man. So if it's your first time, just click on the like button, subscribe to the channel, and until next time, man, stay blessed, stay irie, man. Blow up some candles. Stay blessed.